Computer networks. This is actually a quick second lesson on chapter 2 so that you can actually understand some of the wiring, because it is very important, especially if networking is one of your areas that you're going to go into, to understand what are networks, how they work, what type of wiring is required, because you do not want to mistakenly say that a fiber is what it's actually an RJ45 or a Cat5 when it's not really. Okay, so that's what we're going to be discussing today. And again, I want to actually thank David Wilta, which is actually, he is the author of this book from the University of Washington. So what type of media do we have? Okay. Media propagates signal that carry bits of information. Unfortunately, we live in a world where this media is heavily wanted by a lot of people, right? Which is information across these signals and bits of information that everybody wants the second that they want it. So we're going to be looking at the wires, the fiber optic cable, and then the wireless. The first thing that we're going to do is we are going to start first with basically the most common one, which is a twisted pair, okay, which is reduces the radiated signal. The most common one that we actually have is called what we call a Cat5 UTP cable. And you can see there's actually an example right there of how it is and how it works. Okay, it's actually a twisted pair cable for carrying signals. This type of cable is used in a structured cabling for computer networks such as Ethernet. The cable standard provides performance of up to 100 MHz per second and is suitable for a 10 base T, TX, fast Ethernet, gigabit Ethernet. Cat5 is also used for other signals such as telephone and video. This cable is commonly connected using punch-down blocks and modular connections. Most Category 5 cables are unshielded, relying on the balanced line twisted pair design to differential signaling for noise injection. Then you have the next one, which is called a coaxial cable. Coaxial cable, or known as coax, is a type of cable that has an inner conductor surrounded by a tubular insulating layer, surrounding a tubular conducting shield. Many coax cables also have insulating outer shield or jacket. The term coax comes from the inner conductor and the outer shielding sharing the geometric axis. Coaxial cable was invented by English engineer and mathematician Oliver Hipside, who patented its design in 1880. Coax cable differs from the shielded cable using a carrying lower frequency signals, such as audio signals, in that the dimension of the cable can be controlled to give a precise constant conductor spacing. And then we come down to fiber, which is actually something that it is used very popular nowadays by many offices, many businesses, because it is basically what it is called. It's actually the speed of light. Now, and the whole purpose of this is actually a cable that it contains more than one optical fiber that is used to carry light. The optical fiber elements are typically individual coated with plastic layers, okay, and containing a protective tube suitable for the environment where the cable will be destroyed. Different types of cables are used for different applications. For example, long-distance telecommunications or providing high-speed data connection between different parts of the building. This is actually popular use, especially in businesses or even for cable companies who need to have high speed. And nowadays that a lot of ISPs or internet service providers actually guarantee that users are going to get high-speed internet access, they do use the fiber technology. And like you can see in this example, you can actually test it by one side of the cable, putting actually like a flashlight, and then on the other side you actually can see how the light comes instantly. Okay, so there's the two types of varieties. You have a multi-mode and a single mode. You have one fiber and then you have a fiber bundle in a cable. Okay, you can actually read more about this in the book. wireless, very important. Okay, many directions, unlike wire, to potential many receivers and nearby signals interfere with receiver. So wireless actually has become very popular. Okay, wireless, there's different types of links. You have terrestrial communications, cellular, radio. So let's go ahead and talk a little bit just only like for example, as in terms of like for when we're looking at for example the communications. It is basically it communications via microwave radio waves that are actually detected by the access points, and then all this is actually broadcast to the different types of technologies or actually devices that actually get it. You have different types of networks again, like in local area network connections with this. In general, basically now that the industry is accepting a handful of different wireless technologies, each technology is defined by a standard that describes a unique function to both the physical and the data link of the OSI model. So again, not just because it's wireless, you can do whatever you want. You have to be very careful with that. Wireless access points are also often close to humans, but the drop of the power over the distance is fast. Okay, you have to be very careful because with wireless technology, security is a big issue, and sometimes security doesn't work very well. Again, you have to be careful. Okay, so for example, right here, there's different types of frequencies and allocations for the United States, and you can review the different types of spectrums for the computer networks. And this, again, like this can be found on your book. Okay, wireless. Second, we have microwaves, and their unlicensed frequency, like Wi-Fi, is widely used for computer networking. And there's an example. You have different types of frequencies. Depending on the device that you actually have, it may or may not connect to it. Okay, this is it for this quick version of chapter 2 on basically on cabling or the wiring that I think it is very important for you to understand. Okay, like I said, if you have any questions, don't feel free to let me know.